Hi there, my name is Hao, and this is just another video of me solving random LeetCode problems. So, given an array of integer nums, sort the array in ascending order and return it. You must solve it using n log n, but without using any built-in function. Okay, so it's a bunch of solution to this. We can use OHAB sort, that is can be n log n or less. Um, so I think we can use like either quick sort or merge sort here. I'm just gonna use merge sort. I think like the largest number of in the array is tab over here, right? So technically we can like create, so what is it? 10 to the fourth is 1, 2, 3, 4, multiplied by 5 is 50,000, right? So we have like negative 50,000 to 50,000, right? So technically we can create an array, a counter with 100,000 element and do a count sort for that. And the time complexity would just be like, 100,000, right? I'm not gonna attack this approach today. I'm just gonna use merge sort. So if we have like 5, 2, 3, 1, we're gonna split them in half. For it is the mid, right? Which is like array length divided by 2, right? So what is it? 4 divided by 2 is 2, right? Yeah, so here, right, and we can take slide array from 0 to mid, exclusive, and then mid to the end, right? So it would be 5 and 2, then 3 and 1, right? And we just sort the to second half, right? So this one would be um, 5 and 2, would be 3 and 1, right? So this is our base case, right? We're just gonna return if the array only have 1 or 0 element. So when we return, we can merge them together, right? So this will become like 2 and 5. This will become 1 and 3, right? And we can uh, continue to merge these two as we return up. Right? And we're gonna merge them, right? And we're gonna have 1, 2, 3, and then 5, right? So we just keep pu pushing the element in the first element in our result array. Right? If the first number, because we know that the two sub array is sorted, so if the first number is smaller or equal to the first number of the other array, we're just gonna push this element and increment our pointer, right, until either of the array is empty. All right, so let's code this up. So we need to return merge sort for element. We're gonna have const merge sort. We take an array, right, and we calculate the mid index is array not dot four, array dot one, so by two. You have the left and the right. So array dot slide 0 to the mid index, so exclusive. That's the right mid index. And we're gonna return the merge version of one, right? Left and the right. And we also need a base pair, right? So if the array of line is less than 2, then we just go ahead and return the array, right? Because there's nothing to sort. So we need a merge function here. Merge, we take in array 1 and array 2. Array 1 and array 2. We have our result array. And we want to return the result at the end. Right? We have let's create two pointer for two array, right? Index 1 and index 2. also create the length variable. So not a1 dot length, and then a2 dot length. Then we can iterate through the uh the array 1 and 2. So while I1, the index one, is less than length 1, and I2 is less than length 2, right? So we can check that if the array at index 1 is less than array 2 at index 2, we're gonna push the element from the first array, and else we're just gonna push the element from the second array, a2 at index 2, right? And we also need to increment the index. The reason that I'm using the pointer here is because if I don't use a pointer, I need to pop the element of the array, right? And that is because when we pop the element from the left side, we need to we need to shift reassign the index, and that is will be O of n. So that's why I'm using two pointers here. The y index 1 is less than the length the array length 1, and index 2 less than the length of 2. We just check the condition, right? If it is less than, we push the element from the first array, increment the index, and vice versa, right? So break when we finish the while loop, then because the while loop will break if either condition is false, right? So there's a chance that there are still elements left in either array. So we need to account for that as well. So we will have to return the result, but with whatever remaining left from the two array. So A1 a slide I1, and then A2 the slide of I2, right? So we're just gonna return whatever is left in either array. Okay, and of course this has to be left because we are changing the index here. Okay, let's see. We have A1 dot length, A2 dot length, the result dot push. If A1 is less than A2, then we push the first one. Else we put the second one. We increment the index. All right. Oh, right. I forgot to call the recursion function here. So merge source of the left, and then merge source of the right. So it should work now. Accept it, submit, and thank you for watching.